Okay, now let's continue, and to complicate things a little bit, let's introduce the notion of an experimental design. What is an experimental design, and why are we so obsessed about experimental designs? The explanation is very simple. An experimental design is basically a way to organize an experimental study uh, that allows us to rule out alternative explanations, that allows us to rule out those threats to internal validity that we have just discussed. That's why it is very important to choose a good experimental design. And the good news is that there are already recipes that we can choose from that we can use. But before we actually start approaching those recipes, we need to understand how can we write them down. What kind of notation do we use in our experimental psychology cookbook? And luckily for us, it is much more simple than a cookbook that you will find online. So our Julia Child is Don Campbell, and he has come up with this brilliant approach to write down any experimental design using just three letters, three magic letters, R, O, and X. The letter R stands for randomization. You form groups randomly. And if you put a letter R, it means that you randomly assign people to different groups or different sequence of interventions. The letter O means observation. You measure your dependent variable, and you might do it before and after, or just after, etc. And the letter X denotes treatment, presence of independent variable. So sometimes you have groups where you have X and nothing, or sometimes you have X1, X2, X3, etc. if you compare different interventions. But X is always a certain type of an intervention. And each group, the sequence of things that you are doing with each group, is presented on one line. Before we start discussing the real experimental designs, we might take a look at what Campbell called pre-experimental designs, or basically the ways people used to make causal conclusions before experimental paradigm came around. And for each of those ways of making causal conclusions, he lists which of the threats of validity does this approach allow us or not allow us to control. So if you see in this table a minus, it means that this threat is not controlled. If you see a plus, it is controlled. But if you see nothing or a question mark, it's not clear. It depends on some other factors. And the first very classical and very simple approach to making causal decisions that unfortunately people still apply a lot is called one-shot case study. And it is defined by just two letters, X and O. Something happened to my grandmother, and then she always was like this. This is the kind of reasoning that people apply. But unfortunately, it is not perfect. To illustrate this notion of one-shot case study, let's take a look at this man. Maybe you recognize this picture, which was considered lost for ages, and people thought that maybe it's a whaler with his harpoon. But then researchers have recently proven that this guy pictured here is the only available picture of Phineas Gage. Phineas Gage, who is famous because he's in all textbooks on neuropsychology, because he's such a classical case. Probably you've heard about this story of Phineas Gage, or if you did not, I will tell it. This guy was working at a company which constructed railroads, and his job was to use this metal rod to make holes in the ground. And then, after he made a hole, his job was to put in some dynamite and then gently press it down with the same rod. Unfortunately, one day things went wrong. Phineas Gage put dynamite in the hole, he pressed it with the rod, and maybe there was some kind of spark. The dynamite exploded, and the metal rod went right through his head and blew up off a large part of his hemispheres. So basically, the rod went through one side of his head and went out from the other side, and people could actually see through his head. And everyone said, oh, this guy is likely to die. It's impossible to recover from such an injury. So he was taken home. But then miraculously, in a few weeks and in a couple of months, he started recovering. And miraculously, he was able to even take care of himself. He was able to speak, to interact. So none of his functions really suffered. The only thing that changed in him, according to contemporary reports, was his moral behavior. Before this unfortunate event, he was almost an exemplary person who always went to church, and he did not drink alcohol, and he was all nice citizen. But after this unfortunate accident, he started to visit all kinds of bars to drink alcohol, to visit houses with sex workers, we will say in contemporary language. And he ended up his days by traveling with a traveling circus and demonstrating his head and showing his rod and enjoying his life in all kinds of ways. Now, the question is, the authors of these books on neuropsychology typically say that the cause of this change is due to Phineas Gage's difficulties in controlling his behavior. He became more impulsive because the frontal lobes were injured and prefrontal cortex was injured, and these parts are responsible for allowing us to control our behavior and follow plans. But maybe, as experimental psychologists, you can think of other alternative explanations. Why did Phineas Gage's behavior change? Maybe it's not a result of a metal rod flowing through his head. So I propose you to put this video on pause and think about maybe 3 possible alternative explanations. Why did his behavior change after this accident? And to approach these alternative explanations, we can take a look again at this wonderful table compiled by Don Campbell. Basically, this research design illustrates that post hoc known as propter hoc. After this does not mean because of this. There's the effect of history. Maybe it's not the damage to his brain, but maybe it's the other things that went in parallel. Maybe they were connected to this accident, but not necessarily connected to his brain. For example, other people started treating him as a disabled person, and he started to feel privileged and started to enjoy life more, so to say. Or maybe it's maturation. Maybe it was just the effect of age crisis. And maybe after a certain age, Phineas Gage would begin anyway to visit houses with sex workers and drink alcohol, regardless of whether there was or was not this metal rod. Or maybe it's the effect of selection. Phineas Gage started doing all these things because he was Phineas Gage. But if, God forbid, this metal rod went through the head of, let's say, Albert Einstein, maybe he would have invented another theory connecting relativity and quantum physics. Who knows? And of course, when we try to generalize from such situations, we should always be aware of mortality. Will metal rod make me an immoral person if it goes through my head? I cannot be sure, because most people who suffer from this kind of things, they never make it. So the miraculous case of Phineas Gage might be quite exceptional. And this problem is also very well known. And for the external validity threat, there is interaction of selection and manipulation, which is again pretty much the same thing. This happened to Phineas Gage because it was Phineas Gage and not another person like Einstein. So as you can see, this kind of reasoning, one-shot case study, like smoking is not harmful. My grandfather smoked 3 packs a day and he lived until 100. This kind of reasoning is completely flawed. It does not allow us to make any causal conclusions. Unfortunately, people still engage in it very often. Another flawed research design is called one group pretest post-test design, and each is written down with 3 letters, OXO. We measure something, O, observation, then we do something, for example, we teach children, and it's X, and finally there's another O. We observe again, and we see what happens. And this is exactly the design that was employed by our teacher Dolores when she measured her children in September, then she taught them, and then she measured them again in June. And you can see that there are 5 different threads, or maybe even 6 different threads to validity that are not controlled, and it is only internal validity. So if you see a study like this on one group published in a journal, probably it's not a good journal at all. And it's only possible in case there is absolutely no other evidence for this experimental effect, and there was absolutely impossible to have a control group. Unfortunately, it might happen, but it is a very, very weak source of evidence because alternative explanations are not controlled. So normally it's not used in science. And the third type of pre-experimental design, which is also fairly flawed, it's called static group comparison. And here we have 2 lines, which means we have 2 groups of people, but there is a dashed line in between them, which indicates that these 2 groups are completely separate. They were not formed, they don't come from the same population. And one group has X and O, and another group did not have this X, and they have just O. Let's say, for example, you're interested in the effects of an earthquake. What kind of traumatic experience does it produce in people? Like, for example, a volcano Vesuvius erupts. What kind of post-traumatic stress it produces in people, or maybe what kind of resilience? And you are saying, I will take a bunch of people who survived the eruption of Vesuvius, and I will take another bunch of people from a comparable town in Italy, and I will compare their psychological outcomes, and I will see if there are any differences. Unfortunately, there are 3 threats to your validity. Selection. Maybe people who lived at the Mount Vesuvius initially were different from people who lived in a much safer place. Maybe they had higher tendency towards risk-taking, or maybe they had lower IQ and they just didn't care about the possibility of this volcano erupting, or maybe some other personality characteristics. So these groups are not equivalent. So selection or non-equivalence of groups is obviously an alternative explanation. Another one, mortality. You cannot be sure that this sample of Vesuvius eruption survivors is equally representative of the group of people who lived near Mount Vesuvius. And maybe the reasons why this small bunch of people survived from that original town was exactly because they were very careful and they fled in time. But this does not mean that their psychological characteristics reflect the effects of this earthquake. Maybe it's actually vice versa. And finally, there can be all kinds of interaction possible here. These Vesuvius survivors, as they got older, because they were so special, they changed in a certain way, for example. And that explains their differences that you observe 20 years later between these people and another bunch of people. So this, again, is a very weak research design. It does not allow to make good causal conclusion whatsoever. So to sum it all up, if you want to conduct an experiment and you don't have a control group, it's very hard to make causal inference. Your causal inference will be flawed. It will be very weak, and most reviewers will basically try to destroy your study right when they see it. So what kind of experiments can we conduct that use good research designs?